action.
Now it should.
It's not working.
Still, even if you just do one.
Hey,
Oh.
my name's Jessica, and I'm from the class 2022.
Okay, so today, finding probabilities from a normal curve. Okay, now a normal curve is what typically happens. So like as a teacher, like on a test, okay, in the middle of the normal curve falls the mean. Okay, so that x bar, that's the mean. Now, based off that mean, I would expect 68% of you to fall within what's called one standard deviation. Okay, standard deviation it tells us the spread of the data. Okay, so let's say we had a mean of 85. Well, let's go 75. 75. Okay, and I would expect, a standard deviation of 5. Okay, that's telling me I would expect, okay, if the mean is 75, standard deviation of 5, I'm expecting 68% of the class to fall within 70 to 80%. Okay, so when we break up this normal curve, okay, the mean falls right in the middle. Then you're going to have a standard deviation. Okay, one standard deviation away, two standard deviations away, three standard deviations away, three or more. Okay, and it goes both ways. Now, if you fall exactly on one of those standard deviations, okay, like if I was to say one standard deviation away above the mean, okay, that means you're going to fall within this part of the curve right here. And that is 34% of the curve. Okay. Then 13.5% when you get two standard deviations away. 2.35, 0.15%. Okay. Now, when you fall in between, okay, we call those z-scores, and that's what we'll get to tomorrow. Okay, but today we're going to concentrate if you fall right on a whole number of standard deviations. Okay, so there's the normal curve. Okay, and then you're going to have to know those percentages. 34, 13.5, 2.35, 0.15%. Okay, we should do enough practice where I think we can memorize 4 numbers. Okay. I would agree with that. Okay, so the mean, x bar, and standard deviation of theta of a normal distribution determine the following areas. Okay. Now, anytime we deal with statistics or probability, okay, your answer should never be greater than 1. Because 1 as a percentage is what? 100%. 100%. Do you have anything over 100%? No.
A class.
No, that's with extra credit. If you just look at it as a whole with no extra credit, would it?
No.
Okay. So, again, 1 deviation away, how much is that? 34. 34%. Or you can think of it as 0.34, right? What was that next one? 13.5 or 0.0135. You remember what the next one was?
0.0015.
It's the last one.
Oh.
So that's 0.15%, right? What was that last one?
2.25.
2.35%. Or 0.0235, right? If we think of it as a decimal. Okay, so what we're going to look at, okay, I'm going to give you a mean. Okay, we said a mean of 75 on that example I said earlier, and we had a standard deviation of 5. So if I go one standard deviation to the left, and we have a standard deviation of 5, that puts us at 70, right? If I was to go 2 to the left, what would it be at? 65 and 60, 80, 85, 90. So the types of questions I'm going to ask then, okay, what's, what percentage of students would you expect to get between 70 and 80? 70 and 80, then we got 68%. What would be the percentage of students you'd expect between 65 and 60? Those are the types of questions I'll be asking.
How do you answer that? What was the answer to the first one?
From 70 to 80,
Yeah.
34 plus 34%, that would be
Oh.
68%. So I'd expect 68% of students to fall between 70 and 80.
You just add them.
Okay.
Okay.
So those are the types of questions we'll look at today. And then again, tomorrow, we'll start looking in between whole standard deviation, so like 2.5 away or 1.5. Okay, and I'll have a table for you guys that will tell you those percentages. Okay, so a normal distribution has a mean of 10 and a standard deviation of 1. Find the probability that a random selected x value is given in the given interval. Okay, so we had a mean of 10. Where does the mean fall? Right in the middle. And it said I had a standard deviation of 1. So if I go 1 standard deviation to the right, what's that put me at? If I had a standard deviation of 11, 12, 13. Okay, so now the question is, find the probability that a randomly selected x values in a given interval between 8 and 12. Between 8 and 12. So I'm asking, what's the likeliness that someone falls within that shaded area, correct? Okay, so we said this is 0.34, that's 0.34. What was the next one? I know the percentages when it's 1 full standard deviation away and 2 standard deviations away, right? What would I do with those? Add them up. Okay, 68, 13.5 times 2, that's 17, yeah, 27. 27 plus that 68. You'll have calculators. 95?
Do you just add all 4 of those numbers up?
Yep.
And then move the decimal place?
Yep. I would accept either 0.95 or 95%. Either way. Unless I specify in the directions and say percentage or decimal. Okay, so how important is it to know those percentages in each interval? Very. You need to know those. Okay, so we're going off that same situation still. We got that mean of 10 with the standard deviation of 1. Now it says between 8 and 11. .34, 0.34. What's that second one? 13.5. Add those up, what do we get? Or 0.8150, correct? Either way. Okay, still same situation. At most 10. What's at most mean?
Up to 10.
Up to 10. Can't be greater than 10, right? So everything below that. This one should be easy. It's half the curve that's shaded, right? That's 50%, 0.5, either way. Okay, the whole curve represents 100%, right? You got half of it shaded, 50%. At least 12. What's at least mean?
Up to 12.
Up to 12?
Before, like, more than
12 or more, right? At least, that's the smallest value I want to have. So I just got those last two. What were those last two worth?
0.15.
And what?
2.25.
Add those up, what do I get? What's that? 6.5?
0.025.
Or 2.5%. You can think of it in terms of percents, or you can think of it in terms of decimal. That does not matter. If you do the decimal, you're going to be 0.0235 plus 0.0015 or 2.35 plus 0.15 if it's in terms of percents. Questions there? Okay. The price of sandals is normally distributed, okay, right there it tells us we can actually use the normal curve, okay, with a mean of 36 and a standard deviation of 9. So what number goes in the middle there?
36.
36. If I got a standard deviation of 9, add 9. And then subtract 9 going left, correct? So that gives us our intervals with those standard deviations, correct? Now, what percent were priced between 18 and 72? That's going to be that whole area this way, correct? Now, you can add all those up. Or we just know that this one's 2.5% with these two, isn't it? Can I just do 1 minus that? Add them up, or you can do the 1 minus. Which will give us? Yep. Or add them all up. You got a calculator, right? Add them all up, or you can do 1 minus that 100% minus 2.5%, or 1 minus that 0.025. Either way works. We're going to have to use that idea of 1 minus eventually, especially when we start dealing with z-scores. So, what's the probability that a randomly chosen pair is priced between 9 and 18? Okay, we still got that same intervals, all right? Same situation still. Mean of 36, standard deviation of 9. Okay, between 9 and 18, it's just that one part, right? What's that one part worth? What's that? 2.35, right? We're not including that last bit of that tail. That one's worth 0.0015 or 0.15%. Okay, and I mean, just think about it. Okay, if the average price of something is 36 a pair of sandals, how likely are you to find a pair that's between $9 and $18? It's not gonna be very likely. There might be one store out there, right? That doesn't wanna make any money. But it's very unlikely, right? I mean, the average price is 36. You might be able to find some place that's got $27 pair, right? Or $45 pair. Most likely is 36. I mean, that's why it's the mean. Right? Questions there? The weight of strawberries packed in a medium-sized container was normally distributed with a mean of 16.18 ounces and a standard deviation of 0.34 ounces. If you randomly choose two medium-sized containers of strawberries, what is the probability that both of them weigh less than 15.5 ounces? Okay, so what goes in the middle?
Mm, 16.8.
16.18. Okay, if I go right, what's that going to put us at?
$52. 16.52.
2, yeah. Next one?
16.86.
Next one? 17 point what? Okay, and then if I go left,
16.8.
you sure about that? 15.4,
16.84.
15.5, yeah. So this should be 8.4 here. Okay, and then finally what? 15 point, what's that? 16. Okay, so then we're looking for both of them to weigh less than 15.5. So what area of the curve will I shape? Left or right of 15.5? It's less than.
Left.
Left. Okay, and those two right there are what? Or 0.0250, right? Now, gotta think back to probability a little bit. We're picking two of them, right? So if I go in there, okay, what's the chances that I pick something less than 15.5? 2.5, right? But then again, I'm going into it again. Is that likeliness of getting that container less than 15.5 ounces change at all? Okay, so you gotta remember, the first container, second container, I got a 2.5 or that 0.0250 and 0.0250 chance on both, right? What do you do with those two numbers? Anyone remember? The probability? Two separate events. We're going to multiply. Okay. So, I mean, it's very unlikely you're going to get one of those, right? It's even going to be less likely to get two in a row that size, isn't it? You got to multiply those two probabilities. What do I get, Morgan? Point 025 times 0.025. You guys get that on your calculator, the E? You guys remember what that means?
No.
It's 4 decimal places.
Okay, so if your calculator shows 6.25 e to the -4, that's saying times 10 to the -4. Scientific notation, you guys remember that? Okay, we move the decimal place 4 times to the left. Negative tells us to the left. So if I move that 4 decimal places to the left, that's going to put 3 zeros in front of 6, isn't it? So this is 0.000625. That's what that's saying. And if I do that as a percentage, that's 0.0625%. You need to multiply the two probabilities. Okay, so it's all about making sure you read carefully. This case is 2 separate events, right? Okay. First event, I'm grabbing a container that's less than 15.5. Second event, same thing. So I could say, another way I could go about this is, okay, first container is going to be 15.5 or less. Okay, that's at probably a 0.025. Or, and then to say the second container could be, you know, greater than 16.18. So there you'd have to find 2 separate probabilities, then multiply, correct? On this one, I was looking for that same size container, so the probabilities were the same. But I could change it up a little bit and do it that way also. Make sure to read carefully. If you're picking more than one, you're figuring out the probabilities of all the events and then multiplying in the end. So when we get full standard deviations away, it's not too bad, is it?
Nope.
Okay. It's all about getting those numbers on the bottom of your normal curve correct and shading the proper area. And then you're going to have to know your percentages in each standard deviation though, right? Any questions? Okay, so again, tomorrow, okay, like on today, everything fell right on those standard deviations. Tomorrow, they're going to fall there or there. I could say between or less than or greater than. Not too bad. They fall right on those standard deviations though, it's not too bad. Questions? Okay. Plenty of time to work on homework today, right? Any reason to not get it all done? So you will do not that one.
I'm not gonna do the homework.
12.7 book assignment.
You don't need to either.
Yeah, I even put those normal curves in there right for you.
Thank you for watching. See you next time.